So what we're going to go through and do is identify our Cascade capabilities. We're going to describe the associated CAN bus wiring communication protocol for the Cascade, and we'll explain the vGuide app and the procedure for Cascade systems. The vGuide app to do a Cascade is going to be a requirement with the CI2 and the Vitocrossal boilers. So with internal Cascade ability up to 16 boilers, these boilers, you'll notice here, I do have a shot of that double decker, whether that's a 1.5 and a 2 million, and those single deckers, that 399 through 1 mil models. These can all be cascaded together. It is possible to actually mismatch your cascade and BTU sizes if you want to do it. That Cascade is set up to figure that out. And nice little feature that those displays are in the same level playing field. So when you do mismatch them, it has a nice seamless look to it. With that being said, 2 million BTUs times 16, so we can get up to 32 million BTUs if your mechanical room is large enough. If you do put 16 of those together, as I tell every class or webinar, I want to know about it. I'd love to see that mechanical room and post some pictures about it. Now, when we look at the CAN bus communication, our daisy chain from boiler to boiler, we're going to refer to those as our participants. So each boiler is a participant, and we can also have our BMS integrator in this gateway. This is also going to become a CAN bus participant. Now, knowing where our participants are and how they're wired is going to be paramount in how we turn on a dip switch protocol, which is going to be our end-of-line terminator. Everything is going to be built in to the boilers for those end-of-line terminators. There's only one dip switch in the location, our wiring location for that. The BMS integrator, depending on where it is wired, is going to have a stab-in resistor that's going to be necessary if it's on the end of line. The gateway, there's nowhere to steal power from on the boiler, so we are going to give you 24 volt DC, AC to DC power supply. So you're just going to take this from incoming power that BMS integrator with its DC power supply, and then wire in the CAN bus communication into one of the boilers. It doesn't have to be the lead. That's all going to depend on what might be easier for you to wire. So inside the boiler, we're going to go to the HMU, our heat management unit. This is actually the HMU WP board. It's a wiring panel. And we're going to locate our 91 plug. That's going to be yellow, looks just like this. This is going to be wired polarity sensitive. You can use 2 twisted pair. However, we have done some testing as of late, and just standard thermostat wire, just 2 conductor thermostat wire is going to be fine. Polarity sensitive for low and high to make sure we just wire those correctly. And we're going to have to use our start and end of line terminators, which is going to be this dip switch right here. So that dip switch is going to move to the on position. It is just clear white, but showing you that it'll go backwards this way to be turned into the on position. And we want to do that on our first and our last participant only. Now, when we talk about first and last participant, if we look at this as a 3 boiler cascade, so we have our BMS integrator going into lead boiler to lag 1, and lag 1 over to lag 2. Now, when we look at this, we're going to have BMS integrator is going to be our start of line, and we go through the boilers and we come to our last lag boilers, our end of line. So that means our end of line dip switch gets turned on, and our BMS integrator is going to utilize the stab-in resistor. If we were to remove any BMS integration from this, then the start of line would be our lead boiler. So we would turn that dip switch on, middle boiler's dip switch off, and boiler 3 will have the dip switch on. So we're just going to daisy chain those wires together, again, ensuring polarity sensitivity. So in that 91 plug, we're going to have 2 on low and 2 on high, either from another boiler or from that BMS integrator. Now, when we go to start up the boiler, we have to make sure that they are wired correctly. We have good connections on all those, and you want to make sure that the dip switch protocol is set up in the correct orientation. If that isn't done when we start this process, by addressing the boilers. And then furthermore, we're going to talk about the V-Guide app. It's going to run into a hiccup. I'll point those out as we go through. So you can see right off the bat that maybe something's happening or maybe somebody wired it for you. We want to make sure that everything is set up from the get-go, the first go-around. So we're going to start off on both boilers, or 3 boilers, or up to 16 boilers. They're all going to come from the factory on this main start screen here, where they're going to be set for individual equipment. We're going to have our language here: North American English, Spanish, or French Canadian would be your 3 options in there. We're going to hit this middle application button on our lead boiler until it says lead appliance. Once it says lead appliance, we can go ahead and hit that check mark. We're going to go to every subsequent lag boiler. We're going to hit the application button 2 times. It'll scroll through, say lead appliance, then it'll say lag appliance on the second one. Then it'll allow us to go into our recognition ID, where we can set this between numbers 2 up to 16, making sure that we address the boilers as they are in the daisy chain of the wiring, and then make sure we go ahead and hit that green check mark on all of our lag boilers. Once we hit that green check mark, you're going to see that it comes up to commissioning with software tool. You're going to get this on all your boilers, and on your lag boilers, they're going to automatically go to this bottom right screen where it says commissioning with software tool. It'll actually say ID 2 for your first lag boiler, ID 3, 4, 5, and so on for all your lag boilers. Your lead boiler will be indicated with ID 1. On your lead boiler, however, once the commissioning process has been started, it's going to come up to this black screen here where it gives you the Viessmann ID. This is the Wi-Fi network that the V-Guide app is going to connect to communicate with the boiler. Once we do see this black screen, we want to make sure that you do hit this check mark in the bottom right. So it comes up to this bottom screen here. This way, all your lead and lag boilers will all have this screen on them. The only differentiation would be ID 1 through 16, depending on how many boilers you have connected. Now, once we get to that point, we're going to actually stop using the boiler's HMI, the touchscreen, that human-machine interface, and we're going to move on to our V-Guide app. So with the V-Guide app, by opening it and logging in, commissioning, it does require a full Viessmann account. It's free to use. You can get a hold of anybody in the academy, sales team. Your wholesalers will be able to get you a full account if you don't already have one. Then selecting new system and Cascade system for CI2, we are going to scan that Wi-Fi QR code. Once the Wi-Fi QR code has been scanned, it's going to connect to the lead boiler, and then the lead boiler is going to show you how many boilers you are connected to. What can happen is you're not going to see this screen after connected to the lead boiler. You hit continue, and then it should show you all of the boilers that's connected in your Cascade system. If it does not show you this screen at all, it just moves right forward like it's a single boiler commissioning. That means that none of the dip switches have been engaged or the interconnect wiring for the Cascade has not been completed. If you have, let's say in this instance, we're showing 2 boilers. If you have a 4 boiler Cascade and you're only seeing the first 2, typically that indicates that all the dip switches have been turned on and it's only communicating to the first 2 boilers. So just by altering the dip switch protocol only on the first participant and the last participant only, we turn those on, then you'll see the other boilers pop up onto your screen. Then we can move forward with commissioning all of the boilers in the Cascade at once. Starting off with the V-Guide app, as we're logged into a full account, new system, we're going to go to a Cascade commissioning. This goes through all of the information that we just went through. So if you're going to forget, or it's somebody new on site that's doing this for the first time, it's going to say, select your language, set the parameter of your application type to lead device, then go through and set your language, lag device, set that to your IDs 2, 3, 4 through 16. Then we're going to scan that Wi-Fi sticker on the lead boiler so we can communicate to it. Then we're going to get connected to that lead boiler, giving you the main boiler serial number. Fast forward, after hitting the continue button, we're going to see all the boilers that are in our Cascade. So we want to make sure we're seeing every boiler, the same number of boilers in our Cascade here that are in our system. Then we want to select that lead boiler. It's going to be the only one that's allowed to be selected at this time. We have to start with the lead and hit the continue button. And we're going to go into your basic configuration, whether that's weather compensated or continuous operation. That would be your fixed set point. You can change the language again here. Make sure that date and time is correct. It is going to steal the date and time right off of your phone. I do mention that because if you are someone that uses military time, that will move it into a 24-hour format, so you could alter that back right here. The automatic summer-winter changeover, that's going to be your daylight savings time. So it's going to ask you for a month and a day. So that'll look at what month you want, and then that day you choose, it'll change over on the first Sunday after that day. It's going to be about 9 days off at most. Temperature, if you want to do imperial or metric. Your date and time format, whether you want to do that in your standard US version or European version. If you do put it in the European version, leave somebody a note. Otherwise, the fault codes are going to be real funny. This is your conversion natural gas to propane. So we want to ensure that we are altering that to propane here and then putting those yellow stickers on to alert any future technicians that it is operating on LP. Your flue system type, whether that is single connection or common vented, the flue gas system length. So for the CI2, we're going to put in our combined equivalent vent length. So we're going to look at how much exhaust, how much intake, calculate those overall lengths, combine those numbers together. And if we are doing an intake on the CI2, you're also going to have an intake air kit. That also has some restriction associated with the intake air kit. So make sure we're looking at the correct charts and adding that length as well into this flue gas system length here. You can put your contractor contact details in. I would put in your 1-800 number, that emergency service detail number, not your personal information. Once you enter the contractor details, that will actually come up on the display of the boiler for the maintenance personnel. Maybe this is a large house, that homeowner, to see who to call. Notes for report. This is where you can put in anything like you have this paired with this external third-party control. Maybe it's got this snow melt control on it. What kind of system pumps you used, whether it's Magnas, Viridians, fixed speeds, whatever the case may be. You can put all of that in your notes for report. The other thing for any future connectivity and remote monitoring, it's a good idea to input the boiler's serial numbers, the Wi-Fi serial numbers in here. This way you're going to have this report saved on your phone for future reference to look back at it. Now it's going to ask if all the electrical components are installed and connected. Once we move forward from this screen and we start altering the system scheme, if something isn't wired or you're not finished wiring things yet, the display will start to create fault codes. Just throwing that out there. I know sometimes we kind of have to get the heat on and we haven't finished wiring things yet. So it'll yell at you, the display will, but that's all it's going to do. So if we're going to use a heating zone, so remember zones use thermostats and are controlled by a thermostat with a pump output that can be fixed set point, or it can be on its own weather curve. Heating zones do have DHW priority. So if DHW call comes in, a heat zone pump will shut off. So comes default is unused, zone 1, 2, and 3. So there's a 3-zone pump control built into these CI2s. You have to turn those on as a thermostat call. Once you say it's thermostat call, once we engage that thermostat, it has a corresponding pump output associated with it right in that MZIO board. If you're not using those as a 3-zone pump control, but possibly you have some external safeties, maybe your local codes requires an external manual reset high limit or low water cutoff, you could wire these into those thermostat terminals and just set it to be a safety equipment as well. Then we're going to move on to our circuits or heating circuits. Circuits do not use thermostats. Circuits are going to be a constant circulation. Heat circuit 1 is built into the CI2. It is going to be on by default. So if you do not want circuit 1 to operate, if we leave circuit 1 operable, this means I don't need a thermostat or a demand on the boiler. I just need a cold outdoor temperature and the boiler is going to fire off. This will operate a system pump off of its P2 terminal. So if you don't want that to operate, make sure you go in and put not applicable on circuit 1. Furthermore, you can add circuit 2, 3, and 4 if you'd like. Those are mixed circuits, so that requires an external control board purchased optionally. We would need to know the size of the system that you're controlling because we have to order the three-way valve with it. Those come in various different body sizes, anywhere from a 3/4 up to well over 2.5 inch. And we will control that motorized mixing valve, the system pump, a system sensor through that external control, and then daisy chain that back to the boiler. So to activate circuit 2 as a control panel and a mixing valve, 3 requires another control panel and mixing valve, and again for number 4. So you turn those on, mixer circuit with pump. Then we're going to get into our DHW selection. So are we using DHW? It's going to be cylinder with one sensor is going to be factory defaulted on. So if you do not have DHW, make sure you set that back to not applicable. Otherwise, you can use the cylinder with sensor. That number 5 sensor for the Viessmann tanks does not come with the CI2 as standard equipment. So if you do want to add DHW with our sensor, you make sure your wholesaler, your sales rep you're talking with gets one of those on order for you. You can choose to use the cylinder with sensor and a recirculation pump. So it'd be your hot water recirc pump. That would work off of a time schedule, however many times an hour you program in. Circulation pump operates, and then it's going to rely on the sensor temperature to fire the unit if necessary. Cylinder with a switched input, or as we commonly refer to them as an aquastat in the market, or cylinder with switched input and recirc pump capabilities. Recirc pump would be operated off of terminal P1. Then we have DHW upstream or downstream of low loss header. Depending on how I alter this here, this is going to change whether or not I have this recirc pump capability. So if DHW is upstream of low loss header, that's going to indicate that we are piping it kind of directly off of the supply piping. So the CI2 doesn't have a 4-pipe connection like the wall mount boilers, like the smaller wall mount boilers. So this is going to have just a separate takeoff right off of our supply piping right on top. If I say the DHW is upstream of the low loss header, and I also have an isolation valve that the boiler is powering, the isolation valve will not open during a DHW call as it doesn't want to allow heat out to the system during a DHW call. If it's upstream, I will have a recirc pump capability, but it will not open the isolation valve. If I have DHW downstream of the low loss header, that will open the isolation valve during a DHW call. However, this now will change the P1 pump output terminals, and that will make it a DHW supply pump, losing the capability of a DHW recirc pump driven off the boiler. We can add a recirc pump back to it by adding a P1, an EM-P1 is our pump module, an external control similar to the mixing module to regain a recirc if necessary. But usually with the CI2, the way I see them utilized anyways, even in large residential or that light to heavy commercial, most everybody sets it downstream with that isolation valve typically being bolted right onto that ANSI flange connection. You want to make sure it's open in both calls. So with those mixing circuits, looking at circuit 2, 3, and also circuit 1. So heat circuit 1 and EM-M1. So M1 stands for our mixing module, extension module, mixing circuit. And then heat circuit 1. Heat circuit 1 is going to be right here. So we're just showing some redundant pumps. And these pumps would be operated off of our P2 terminal in the boiler. Possibly these are going to be your self-rotating Bluetooth pumps. And then we have your circuit 2 and circuit 3 are both mixer circuits. Here's the motorized mixing valve. We're going to have supply sensors going out to test the supply output on this. We have our boiler pump operational. Boiler pump is run off of the DIN rail on the back of the boiler. We have that DHW is downstream of our closely spaced T's, low loss header, buffer tank, which means that we have no DHW recirc capabilities within the boiler any longer, but we have P1 DHW supply pump, heat circuit 3 with that extension mixing module, heat circuit 2 extension mixing module, as well as heat circuit 1 built into that CI2 being driven off of that P2 terminal. All of our application guides can be found on our website within the Pro Toolbox, and they are just going to be in the current manuals. You'll find some application guides for CI2s, Vitodens, CA3Bs, all sorts of good information in that Pro Toolbox, showcasing you exactly how to add mixing circuits, the pumps. We're going to have those rotating pumps off of our start signal from P2. And that P1 is going to be that DHW supply pump. If you're doing this in a just variable primary where we don't actually have any low loss header, closely spaced T's, buffer tanks, and anything of that nature. So we are going to have some isolation valves on this system, and their boiler pumps are going to be boiler isolation valve. This is going to have your one system pump up here. Depending on what's on the system out in here, these are usually a variable speed pump. But this is going to be DHW upstream of low loss header. But what I want to showcase here is in this scenario with our isolation valves down here on the return, we're actually going to close off flow to each one of these boilers when that DHW call comes in, is these valves are going to close if we set it to upstream. So we want to maintain flow down through our system. So it's going to shut off most likely maybe our zone pump, or maybe this is controlled by others, or we've sized everything to run in a non-priority standpoint. And we want to set this to be downstream, even though technically it looks like it's upstream, to ensure that our isolation valves would be open in this scenario to drive this pump to be able to circulate the water through our boilers and in through the tank. Typically, the downstream scenario we would look at would have those closely spaced T's where we would need the DHW loading pump to operate, as well as boiler pumps to operate, and not relying on just that system pump like we're looking at in this variable primary. So no closely spaced T's would change that nomenclature usually, but with those isolation valves added to it, we want to make sure that we are opening those isolation valves. Whereas in this scenario, we're relying on the flow of the boiler pump. So using boiler pumps to your advantage might help you change whether that's upstream or downstream, whether or not you have the isolation valve or not. Now we're going to get to plug 96. So function of digital input. They did just make an update in the V guide, so this will say plug 96 for better reference to understand what we're looking at. That can be set as an external demand, and this is just a dry contact in the boiler. So the plug 96 is sending voltage out. Make sure that goes to a dry contact switch for our external demand. Pool, spa, maybe a snow melt. External demands will have to be set up in a VDD afterwards in a parameter to set their temperature. Factory default is going to be set for 140 degrees Fahrenheit. This will just give the boiler a fixed set point demand, but it doesn't just go to that set point. If there's a higher requested temperature above that, it's going to go to that temperature, but it doesn't see any warm weather shutdown with external demand. It'll always run to that temperature. You can have external demand by itself or keep DHW recirc pump operational in its program time during an external demand call or shut it off. External blocking for your BMS. If they want to reach in and close that contact against plug 96, that will shut the entire boiler down. Or you could have that as a call for heat. There is no pump output associated with this call for heat. However, if it's coming from a third-party zone control panel, maybe they just want to give it a call for heat from BMS, Techmar control, whatever the case may be. Is your boiler operating its own boiler pump? Yes or no? Remember, this is going to wire to that DIN rail in the rear of the boiler. And like always, if the boiler has a Viessmann logo on it, there is not a pump that can be connected to it larger than 2 amps. So if your pump is larger than 2 amps, you can use these 120 volt outputs for your start relay, but make sure we're not direct connecting anything larger than 2 amps to any pump output. Now, is it an on-off controlled pump? We have the option right off of the DIN rail right next to your line voltage connections for a 0 to 10 volt, so we can control a variable speed. Or is that a common boiler pump for a Cascade system, which would only be on-off controlled? Typically, that's just going to have its own delta P pump, and we could turn that on and off if you'd like. If it's a single boiler pump for each individual boiler, we can do 0 to 10 volts. Those 0 to 10 volts can either follow modulation or we can have a delta T control. If I select either of these two options for follow modulation or delta T, furthermore, after commissioning is completed, you're going to be able to see different parameters or those VDDs open up where you'd say go into it and say at high fire, I want the boiler to see, maybe it's 8 volts and at low fire, 3 or 4 volts, whatever the case may be, to keep it in the knee of the curve you're looking for. And if it's a delta T controlled boiler pump, then you're just going to go in and tell it at high fire, I want this delta T, and at low fire, I want this delta T, whether they alter or maybe they're the same. And then that'll drive your pump with a 0 to 10 volt control based off of the boiler's internal supply and return sensors. EMEA1, so this is an extension module, extension accessory. There's a possibility to add an EA1 module to get some read data out into the system somewhere. However, the MZIO board is essentially an EA1 module. Not very many use cases for it. There are a few, but typically we don't see the EA1 function being used all that much. Remote controls. Remote controls are going to be the Vitocrossal 300 remote operating display, or Vitocrossal 200 rather. And that's a remote operating display and can also be feedback, so room feedback sensor. You would need to update a parameter in it to make sure that it is actually accepting room feedback in the boiler. That would be used in conjunction with a heat circuit to alter its heat curve and either be additive or subtractive from it, depending on how you're utilizing those circuits. Do we want to make additional settings? If this is the first commissioning as we're talking about today, always yes. If you were just going in to make one subtle change, maybe you could go no at this point, but on first startup, let's always go yes. In this scenario, we're looking at a heat circuit 1. In those commercial boilers with the CI2, a lot of places we see circuit 1 is you're just maintaining that building loop. So we could say main floor, maybe it's your building loop, monoflow, if it's a really old system, maybe. Give it those hypothetical room temperatures. We could give it a program because just like a thermostat, since we're not using a thermostat with a circuit, we can have setback schedule if you want it. Do that on a 7-day week schedule. We can pick its own heating curve. We can give it minimum and maximum flow temperatures. So if you're using things like air handlers, this is actually really good to utilize a circuit as opposed to a zone. Giving it minimum and maximum temperatures now is going to give the boiler a completely different curve available to you, where I can extend a lower minimum flow temperature longer into the season and say have 130 degrees until I get to about 30 degrees outside and then start climbing up to 180 for that air handler, versus just a typical curve that would be anchored. That'll just give you 130 to 180 on a quick slope, as opposed to your circuit gives you that hockey stick curve. You're going to go through and put your domestic hot water set point temperature, time program if you do want to turn it off during the weekends, if it's on a business or something of that nature, your recirc program, and then whether or not you want to operate a hygiene function. If you choose to use the hygiene function, you're going to activate it. Then you're going to choose a day, what day of the week, and a time. For the day of the week, you can also choose daily. Once you activate the hygiene function during the time frame, it is going to hold your domestic hot water tank at 149 degrees for at least 1 hour. So make sure you're using tempering valves on the outlet. Make sure we don't scald anybody um, on the outlet for that DHW. If you do come into anything where you want to downfire the unit, so the CI2, I can downfire both the heating side as well as the DHW side, so I can load match the boilers. So if you're utilizing it, I always like to use Warwick, U.S. headquarters, Canadian headquarters, and Waterloo as well. Not a lot of showering and DHW usage. You know, there's hand washing and things like that, and some dishwashers that run, but we don't need the maximum DHW output, but I have a lot of building to heat. So we usually leave the heating output close to 100, and then our DHW output, we can just knock those large boilers down just to load the small indirect tanks that they supply. You can put maintenance intervals into these in 6, 12, 18, or 24-month intervals, or you don't have to do any month intervals. You also have the option of burner run hours until next maintenance as well, or you don't put in any maintenance and you get them on those 5-year maintenance contracts and get away from those unwarranted middle of the night service calls that was just a maintenance reminder that came up. It's going to tell you lastly, just to make sure that you perform a filling and venting on the system. So we're going to go through into actuator test and make sure we actuate all the pumps in the boiler and open all the valves to make sure that the unit is going to be free of air for that first fire up before we engage the burner that first time. And then your commissioning is going to be completed. Now this is just the lead boiler, so we're going to have to go through and do our lag boilers. So system preview, we've commissioned our lead boiler. We got that green check mark. And now we're going to go through and make sure we push commission additional devices. We want to go through and commission those lag devices. Then it's going to highlight all of your lag devices. Shown here was just a 2-boiler Cascade, but you would see all of your other lags in white. You could select any lag boiler at this point. Select that lag boiler. We're going to go through, hit continue. Then it's going to ask you, is it a single connection or common vented? How much exhaust and intake, that combined equivalent flue gas system length is? Are the electrical components connected? And we're going to be able to use those heating zone inputs on your lag boilers. Those are going to be safety inputs only if required. So we're going to lose those pump output capabilities. So you'll see it's unused or safety equipment on our lag boiler. If we choose to make additional settings now, it's just going to ask us if we want to downfire the heating side of that lag boiler. And with that, your commissioning is completed on your lag boiler. So the lag boiler is just a couple of quick questions, gets most of its information from that lead boiler. This is why we want to make sure that they're all communicating and set up correctly before we start making those adjustments. Making sure that we do see that system preview with all the boilers right at the very beginning. And then you will see that again periodically. This would also be commission additional devices here as well if we needed to do any more. Lastly, it's going to ask us about our sequence strategy. So dynamic or fixed. This is going to be dynamic is going to rotate our lead and lag. And fixed, we can do fixed first, fixed last, typically used if you're doing a mix match of BTU sizes, starting that smallest BTU boiler first and always, and then that larger BTU boiler coming in last if necessary. For runtime optimization, this is how long we're going to allow the burners to operate before we do the rotation, adjustable between 50 and 999 hours. Factory default is 200 hours. Then we are going to have fixed. If you choose your fixed ID, it'll go through and say select which ID you want fixed first, then fixed last. and just select each one based on the ID that you've provided that boiler, and you can put that in its own sequence. And then lastly, type of DHW heating. You have local or you have global. With local, the tank is directly connected to the lead boiler, and the lead boiler only would operate for DHW heating. That may be the way you set up your system. Most people want the entire plant available to do DHW heating. This way, if the lead boiler were to have a fault code, ignition failure, or something like that, a lead boiler or a lag boiler rather would be able to take over and still load that indirect tank. That setting is global. This means the entire Cascade plant is available to operate for DHW heating. Once we've made those final settings, it'll ask us, do we want to look at a commissioning report? That commissioning report is going to be generated in your lead device and then subsequent lag devices, depending on how many you have. You can share those reports. They will be stored on your phone. However, we always recommend sending in an email, a Dropbox. You can text a PDF if you want, something that gets it off your phone and somewhere safe, because when you upgrade your phone, or your phone decides to upgrade itself and go for a swim, you will lose that information when you re-download the app, or your phone, breaks for whatever reason. So that's the commissioning process that we go through in the V guide, and there is going to be some things that are missed based on how your system is set up that we're going to want to go through and turn on after we do this. So we're going to do this through the parameter sections. So on the lead boiler, we're going to do a filling and purging process. Going to do that probably on both our lead and our lag at the same time. That's just going to actuate all those pumps, make sure our valves are open, everything like that. Those can be found in your actuator test. Once we have all the air out of the system, we're going to use that actuator test as well for combustion analysis on both boilers, those gas pressure checks, voltage testings, water quality testing. Only need to do that once because it's all the same system. BMS and Wi-Fi communications, if applicable on your system, will have to be once your Cascade is set up. Once all of that is started up, then we can go through and do BMS. Please don't try to do BMS first. It won't communicate to them. We have to address them and commission the boilers first for BMS to communicate. And Wi-Fi, they do need to be commissioned first so that we can get the Wi-Fi, or these do support a LAN hardwired connection as well. So accessing the service layer. So to get to the actuator test on the lag boilers, you're going to have to get into the service layer. On the lead boiler, you're just going to select the menu, find the service tab, put in the password, which is VI service. This is in the manual there. To get into your service layer, to get into your service functions, actuator test, high limit safety cutouts, turn on pumps, do our high and low combustion testing. On your lag boiler, however, it's a little more difficult. So at startup, we're going to test that low water cutoff that comes with the boiler. So once you create the fault on the lag boiler by using the test switch on the low water cutoff, you'll be able to select the icon, the red triangle icon, which will showcase your faults. With that fault list, you can push the small wrench icon, and that'll pop up the service menu password, and that'll give you access into your service functions and the entire screen to operate any high limit safety test, combustion analysis, anything that may be necessary on those lag boilers as well. Commercial boiler warranties. That is a 2-year parts, 10 years on the heat exchanger for all commercial boiler warranties. You can also monitor these boilers. That's going to be through the use of our V-Guide web and monitoring the boilers. So large residential could use a VCare app. If it is a commercial boiler, however, they're going to not use VCare to remote monitor it for the building owner. They're going to get a different kind of V-Guide app. So we do have some seminars that go over commercial stuff. It's a little bit more than we can get into today with the time slot we have, but slightly different because building owners can have more than 2 properties, whereas VCare can only have 2 installations associated with it. So this is your residential uh, my lake or mountain house in my primary home. And then V-Guide, I own a bunch of homes if I'm lucky, or a bunch of buildings. We're going to use a V-Guide app set up slightly differently than our contractors are. With that, it does bring us to the end of our seminar today. We do have some Pro Toolbox stuff here that I mentioned earlier. If you want to find the application guides, any of our current manuals, things like that. How do we do with questions there, Rich?
Ken had asked about he'd commissioned a two boiler Cascade with two different size boilers, and he wanted to make, I believe the small one the lead, and couldn't find the Wi-Fi sticker for it. So just to make sure I'm correct, because I've been a little more in tune with the residential products, and I believe CI2 is the same, but there should be a duplicate Wi-Fi sticker on the TCU, the Wi-Fi generator, in the back of the HMI. That's correct, right? So,
That's
so
correct.
we,
However, just real quick, I do want to interject because I almost broke a screen doing this myself. On the CI2, unlike the Vito Dens, on the back of the HMI, there's two small screws, and you have to remove those two screws, or you'll snap the HMI in half when you go to pop it off the front of what I refer to as that carriage, the plastic holder of it there.
Yeah, and I think Patrick makes a great point, right? If your install world is largely residential, you're putting that HMI on, and you're probably noticing the additional sticker stuck on the back of the TCU or the component that generates the Wi-Fi. With CI2, the HMI is installed, and if you don't have a reason to remove it, you just might not think to look there. So, but it should be there if you are in that
Yep.
case where you lose the loose stickers. Should always be one on the Wi-Fi generator itself. Just as Patrick said, take some care in removing that from the CI2.
And what I actually do if that does happen personally, instead of just getting after that one that's on the back, if they happen to have the stickers that are on the lag boiler, I just swap the screens permanently, um, because they're completely interchangeable, and then you have those extra stickers, and you don't have to keep removing the HMI every time you need to connect to it in the future, things like that. But you can absolutely swap those HMIs around on all the CI2s, and then
Right.
adversely every Vito Den screen, whether it's a 100 or interchangeable and a 200 or interchangeable. But
Right. Essentially, no brains in the HMI. It's really just a human machine interface, right?
yep, just
The
an
brains are
interface.
in the HMU and the BCU. So,
The boiler serial number not embedded in that sticker information. No, so the sticker that you lost on that one boiler somebody lost for you, that is just the Wi-Fi information for that TCU. The actual boiler's serial number is engraved into the return piping. There's a metal plaque that is welded to the return piping with the serial number engraved on it. There's also a sticker as well, but a nice engraved serial number. Now, with the one that is on the boiler, something that is often missed, the way they do the serial numbers over in Europe is you do have the front section of it, and then there's going to be three letters just off to the right. They're spaced out like you wouldn't think it's part of the serial number, and those last three digits are, in fact, part of the serial number. But once you do a Cascade system, when you do connect to the boiler with V-Guide, it'll pull up the boiler serial number through the Wi-Fi, but it won't pull up the Wi-Fi information. And then the sticker has the Wi-Fi information as well as a separate sticker on the rear of the boiler that'll have that sticker as well as that welded plate will both have the serial number of the main boiler itself, but they are
yeah.
different serial numbers. That's a great question.
Yeah, and I think conceptually, right, the TCU or the Wi-Fi generators is a replaceable part, right? That could potentially
Hmm.
fail, and you obviously can't have the same serial number as the boiler, as it may be replaced during the lifespan of the boiler.
Yeah, typically if they get wet, that's about it.
Yeah. Yeah, it's electronic, right?
Yeah.
So no
Or
no
maybe
real
if you
moving
installed one
parts.
maybe outside in the desert and you melted it, that, that.
All
Have a great one, everyone.
right, that's it.